Well, we're going to try something a little bit different in this unit. I'm going to try and approach this a little bit differently in that I'm going to make some videos and have you guys do some of the notes at home so we have more time in class to practice things when things get a little bit more difficult. So this is our next unit, and Unit 9 is all about chemical reactions, and which is kind of exciting because so far we've just talked about some theoretical things, some concepts, but now we get to actually apply them. So this is good. So the main ideas we have are balancing chemical equations. So this is it can be a little bit challenging, but hopefully you've tried them before in maybe Physical Science 9. If not, that's okay. We'll dig into it. And even if you have, these will probably be quite a bit more difficult. We're going to classify reactions. In other words, split them up into types of reactions, which is really helpful when we're trying to predict what's going to happen. Once we classify them, they often have some common products, and this kind of helps us do some predicting. Solubility is pretty important. If we mix two things together, are they going to turn into a solid? Are they going to stay in an aqueous form? So we're going to learn some solubility rules, what hooks together and makes a solid and what doesn't. And the last idea is something called metathesis, probably more commonly known as double replacement reactions. And it's really where ionic compounds switch partners and what kind of shakes loose from that. So here are our unit objectives, and they're listed on your homework packet, on your quiz, on your notes, and so forth. And we'll just take them one by one and kind of focus on this first one for now. So this video is really going to be about chemical reactions and just kind of introducing the topic. We'll talk about what constitutes a chemical change, what signs we see, and just talk about the basics in a chemical equation. So a chemical reaction is really this process where I change the composition of a substance and turn it into something completely different. So this is a chemical reaction. And we often see all kinds of different signs or evidence that this is happening. It could be temperature change. And I'm not talking I put it on a hot plate or I put it in the refrigerator. I mean, it produces a temperature change on its own. I mix two things together and I can put my hands on the side of the beaker and it's warm, it feels warm, or maybe it's cool to the touch. We have color changes, and this could be anywhere from leaves changing colors outside in the fall to we're mixing two things together and we see the solution changes from blue to green or blue to clear, like we actually saw towards the beginning of the year when we were using copper solutions and aluminum metal. Odor is another big one. A lot of times there's a smell associated in particular to a gas that's being produced. Very common in decomposition reactions. Gas bubbles, so again, a gas is forming. Or even a solid being formed, or what we would call a precipitate. So when we're going to represent chemical equations, there's several different ways we can do this, but some of the basics here is our reactants are what we're starting with, and that's always on the left-hand side, and our products are always the substances that we end up in, and those are on the right-hand side. And then we use a bunch of different symbols to kind of separate things and identify some of the specifics. A plus sign right there, obviously we put those in between compounds or molecules that are reacting or being produced. An arrow right in the middle, that's always separates the reactants from the products. In a word equation, we would see this as yields or produces, something like that. Now, there is such thing as a double arrow, which just means the equation or the reaction is reversible. And this is actually quite common, but we're not going to really get into this too much in first year. Now, the last four symbols that we see here are physical states. And solid, liquid, gases, aqueous, all pretty common. And they have to be specific to the compound or the molecule listed in the equation. So there's three different ways that we can represent an equation. One is a word equation, and just means that we have the words for the reactants and the products. For example, aluminum solid plus bromine liquid yields, that's what that arrow sign means again, aluminum bromide solid. And notice that we do have physical states on all of those. The second thing we can do is called a skeleton equation. And this is just taking our words and making them into formulas here. So aluminum becomes Al, solid. Our bromine liquid becomes Brl, with a L in the parentheses there. And yields, so we have an arrow sign, and aluminum bromide. And please notice right here with the aluminum bromide right here, make sure that we're looking at it right here. Aluminum bromide, it's balanced. Aluminum has a 3+ charge, bromine has a -1 charge, so AlBr3. And really that's the biggest difference that we see between our word equations and the skeleton equations. The formulas are completely created and balanced there. But what we don't see balanced is I don't have coefficients to show over here that there were 3 bromine going in and 3 bromine going out. So relative amounts are missing from skeleton equations. That's the one thing that they're really missing. And so the third way to represent a chemical reaction is really just the balanced equation. It's taking the skeleton equation and making sure that we have coefficients to represent the amounts on both sides. Okay? And that's where I'm going to stop on this one, on this video. I'm going to pick up a second one to talk specifically on how to go about balancing equations, but hopefully this gets you at least a pretty good idea of what we're going to cover here. Okay?